What's up, everyone? Welcome back. Patrick here. Moving on to the next question. We have to determine the value of m so that each of these system of equations does not have a solution. So just in general, if you remember, if a system of equations does not have a solution, it means that the two lines don't have an intersection point. And so they're basically two parallel lines. So starting with number one, notice we got here 2x minus 5y equals 1, and then we got 3x equals 2 minus my. Now there's different ways you can go about this. One way is you can line everything up. So if I rewrite these, and then this negative my I'm going to bring over. So notice we'll have 3x plus my is equal to 2. So when I say line them up, notice all the x's are lined up, all of the y terms are lined up, and then the constants here are lined up. And if two lines are going to be parallel, it means that the ratio of the coefficients in front of the variables is going to be constant. So that means that if we take the ratio of 3 over 2, that's going to equal the ratio of m over negative 5. Or we could have did 2 over 3 equals negative 5 over m. Same thing. And so from here, what we can do, we could solve for m. Notice we could cross multiply, so we'd have negative 15 equals 2m. So then m would equal, divide both sides by 2, negative 15 over 2, like that. So that's actually the answer for the first one. So that's one way to go about it. Now, you can also check this answer. So what we can do is we can take both lines and we could put it into y equals mx plus b form. Because if it's going to be two parallel lines, what's going to happen is that both of these lines are going to have the same slope, the same m value, but they're going to have a different b value, meaning they're going to intersect that y-axis at different points. So it's going to look something like that. So the b value is going to be different, but the m value for both lines is going to be the same. And it could also be a downward, they could be downward sloping lines. They don't have to be positive slopes. So if I check this, notice how 2x minus 5y equals 1. So if I take this line and I put into y equals mx plus b form, I'm going to bring the negative 5y over, I'm going to bring the 1 over, and it become minus 1. And so divide everything by 5, we'll have 2 over 5x minus 1 over 5, like that. So this line here, let's write it over here, the equation is 2 over 5x minus 1 over 5, like that. And now what we could do, we could take the second line with that m value that we found, and then put that line into y equals mx plus b form. So if I do that, you know what, let's just put it over here. So we'll have minus 15 over 2, y, like that. Now what I'm going to do to get rid of this fraction first is I'm actually going to multiply everything by 2. So we would have 6x minus 15y equals 4, right? The 2's here would cancel out. And then same thing, I'm going to isolate for this y value. So I'm going to bring this over, I'm going to bring the 4 over. Divide everything by 15, so we would have y equals 6 over 15x minus 4 over 15, like that. And then notice the 6 over 15, that simplifies to what? 2 over 5, like that. So notice, same slope, but a different b value. And so they're two parallel lines that are not touching, and so they don't have a solution, meaning they don't intersect at any point. Right? So you could find it, and then if you have the time on a test, you could also check your solution. So that's the answer for number 1. Now with number 2, notice that here, this line, it's already in y equals mx plus b form. right? So notice that this whole thing is the slope. Now this m and that general m is not the same thing. You may want to even use a different variable here. We could put n. But this whole thing represents the slope of this line, and then the 5 is the b value. So one way we can go about it that would be different than the first way is we could take the second line, put it into that same format, y equals mx plus b. So I'm going to bring the 9x over and then divide everything by 12. 12 over 12 is just 1. And then notice the negative 9 over 12, that simplifies to what? Negative 3 over 4, like that. And so if two lines don't have a solution, they have to be parallel, meaning negative 3 over 4 has to equal negative 3 over m. This slope and this slope have to be the same. And notice that the b values are going to be different. So it's not going to be lines that are right on top of each other. They're going to be two separate parallel lines. And then from here, it's easy to tell that just 4 is equal to m, right? Because the numerators here are the same. But if you did want to go through the whole process and cross multiply, divide both sides by negative 3, m would be 4. Right? So that's one way to go about it. Both slopes would be the same then. Another way, if you wanted to do it the same way we did here, what you can do is you could take this line and put it in this format here. And so what you can do is you can actually take everything and multiply it by m, okay, to get rid of this denominator here. So we would end up, if I take all of this, multiply it, I'll have my equals, the m's cancel out, we'll have negative 3x plus 5m. And then we'll still have this, this line I'm going to keep like this. And then I'm going to take this line and put it in this format. So this negative 3x I'm going to bring over, so I'll have 3x plus my equals 5m. Remember the 5m, that's just a constant because the m is a constant. And then I could take this, let's put it right under this. And remember, these ratios have to be the same. So we could say 9 over 3 is equal to 12 over m, like that. And then cross multiply, 9m is equal to 36, so m would be 4. So that's another way you can go about it, right? So either you're taking the lines, putting them into y equals mx plus b form, the slopes have to be the same then. And then if the constant that you're looking for is in one of the slopes, then you can figure it out like that. Or these ratios have to be the same. Now, the ratios and the leading coefficients in front of the variables have to be the same, but if it doesn't have a solution, then this ratio has to be different than this one. So if we plug in 4 for m here, notice we'll have negative 12 over 20. Right? This would be 25 times 4, and then notice that this ratio here, it simplifies to what? Negative 3 over 5. And then notice negative 3 over 5 is different than 9 over 3, which is 3, or 12 over 4, which is 3. These ratios have to be the same, but then the ratios of the constants have to be different. Those b values have to be different. Now, if all the ratios were the same, that means it would be an infinite solution case, meaning that it would basically be the same lines, right? They would have the same slope and the same b value, so they would intersect at infinite points. It would be the same line. But if they don't have a solution, the ratio of the coefficients is the same, but then that ratio has to be different than the ratio of the constants, right? Or in the y equals mx plus b form, the slopes have to be the same, but then the b values have to be different.